Welcome to a talk about Mauna Loa, and are you ready for the next eruption? My name is Frank Trusdell. I work at the U.S. Geological Survey's Hawaiian Volcano Observatory. What can you do if you live on or near Mauna Loa with respect to hazards? A few simple steps that you can take is to learn about the volcanic hazards that could affect where you live and your community. And this talk will focus on helping you understand lava flow hazards. Other things you can do is to develop a plan with your family. And the third thing you can do to stay involved in and notified of potential volcanic hazards is to sign up for emergency notifications. For Mauna Loa, all eruptions in the historical period have started with a summit phase. This is important. If Mauna Loa is going to erupt, and eventually, if the flanks of the volcano are going to be inundated with lava from the rift zones, there's going to be a summit phase first. That should be everyone's alert that the volcano potentially can come to your neighborhoods. Where can you get information? You can sign up at the USGS for Volcano Notification Service using the URL. If there's any change in the status of the volcanoes in Hawaii, on Hawaii Island, we will send out notifications. As an alternative, you can sign up for county CD alerts. Now, the CD alerts would include volcano notifications, fire, road closures, etc. The important thing to know about lava flow hazards on Mauna Loa is where you live affects the amount of time that you have to respond to an eruption. As I stated before, this talk will specifically focus on lava flow hazards from Mauna Loa. There are other kinds of hazards that can affect you, such as earthquakes and fog and ground cracking, but this talk will focus on lava flows. In order to understand lava flow dynamics on the island, it's important to know where the source of the flows potentially are. In blue are fissures that represent lava flows from the summit of Mauna Loa in the caldera region. To the north and east are shown in red fissure vents from the northeast rift zone, and they trend in the general direction of Kilauea, and geographically this area here is from Mountain View to Glenwood. On the south side of the island is the southwest rift zone. It extends from the summit caldera down the flank of the volcano all the way out to Kalai or South Point. And to the north and west are these dark brick red lines that represent radial vent fissures. And these fissures erupt on the north and west side of Mokuaweoweo from beneath the ocean in the submarine environment all the way up to the summit of the volcano. Historically, there have been 33 eruptions from Mauna Loa. Approximately half of the eruptions erupt within the summit of the volcano, the caldera, and the flanking regions up high, And fissure eruptions have broken across the caldera, and lava flows that have been created from these eruptions have gone 10 to 15 kilometers away from the source. So in reality, these lava flows have not posed a threat to communities living on the island. To the north and east is the rift zone, northeast rift zone. It has resulted in about 25% of all the eruptions in the historical period. The middle portion to the upper portion of the rift zone has been active most recently. And in the recent past, lava flows had a tendency to erupt, and the flows head to the north in the general direction of Mauna Loa, then eventually following the natural drainage in the direction toward Hilo. Along the southwest rift zone, the lava flows are distributed more evenly along the entire length of the rift zone, with flows going east and west of the rift zone. Unlike the northeast rift zone, the distal part, the lower part of the rift zone, has been inactive in historical period, only the middle to upper portions. Finally, there have been 3 radial vent eruptions, accounting for a small percentage of the historical eruptions. In 1852, a radial vent propagated north of Mokuaweoweo, resulting in a lava flow that bypassed and went in the general direction of the Weather Observatory. In 1859, there was an eruption on the northwest flank of Mauna Loa. It sent lava flows skirting the north and west side of Hualalai, with ocean entries in the vicinity of Kiholo and Keawaiki. And then in 1877, there was a summit phase eruption. There was few hours to days of earthquakes, and then eventually a fissure broke out in the submarine environment in Kealakekua Bay, sending glowing, floating rocks, sulfurous gas emissions, and dead fish. Recent bathymetric surveys have been able to document the vents from this eruption. Flows from different portions of Mauna Loa can travel quickly in some sectors. So different portions of Mauna Loa will result in different periods of time that people have in which they can respond to a lava flow. Lots of people have seen my talks in the past. They're familiar with this map. The map shows, in general, the slopes on the volcano. The warmer the colors, the steeper the slopes. For example, if you look at the upper portion of Mauna Kea, you can see these intense red-orange colors. So the slopes are very steep. The large numbers represent average effusion rates in millions of cubic meters per day. And then the numbers associated at the coastline are the transit time of lava flows from their source vents and when they open to the flows actually hitting the sea. The other thing unique about South Kona is the distance from the rift zone to the ocean is relatively short. So you have high effusion rates, you have steep slopes, you have a short distance, and that results in rapid advance of lava flows to hit the sea. In general, this sector is a matter of hours in which you have to respond. To the north and east, you have approximately half the effusion rate. More importantly for this area is you have steep slopes up close to the rift zone. Lava flows rapidly advance down to this high area in the saddle. In the saddle there, you have gentle slopes. Lava flows quickly exit from the rift zone down the steep slopes, and they come into this region of low slope. Therefore, the lava flows start to slow down their advance rate. They start to widen, and yet the source vents keep piling up lava and in this area of low slope. This results in there being a logjam situation here, and secondary and tertiary flows initiate. So that's good for the people on the northeast side because you have a division of lava flows, secondary and tertiary flows consuming the volume of lava available. It also results in a slowing down of the advance of the flows in the general direction of Hilo. The one example that's clearly demarked here is the one in 1880-81 eruption, where it took over 280, well, it took about 280 days to reach within the city limits of Hilo. In the case of the radial vent eruptions, we really have only one well-documented case, and that happened in 1859, where the flows started at 11,000 feet, made it down here in the ocean, the A'a phase, in 8 days, and the Pahoehoe phase at Kiholo took over 100 days. So in South Kona, these are all A'a flows, steep slopes, short distance, high effusion rates, really rapid advance times of lava reaching the ocean. Here's a picture looking from Ho'okena into South Kona in the direction of Miluli'i, and you can see the 3 different lava flows from Mauna Loa all arriving at the sea in less than 1 day. In order to simplify the message of the previous slope map, we've decided to color code the response times from volcanic activity into these different colors. The warmer the color, the shorter amount of time that you'll have to respond. Using the high effusion rate, steep slopes, and for shortened distance, you basically in this magenta area will have only approximately hours to respond. As I stated before, there's going to be a summit eruption first. Everybody should be on high alert then. It's possible that if the flows venture into the Southwest Rift Zone, they could be in the ocean in 3 hours. Those of you who work up in the Kona area or North Kona area, and now you have to try and make it to the South Kona area where you possibly live, this will present a challenge. On the other extreme end is the region of Hilo. Because of the moderate to gentle slopes in the highlands, flows have a tendency to slow down and divide, and it will take a very long duration eruption of very focused activity to send lava flows quickly in this region. But using the historical cases, you have weeks to months to respond. So they have a different period of time in which they can deal with a volcanic eruption from Mauna Loa on the northeast rift zone. To the north and west, this area is orange because it sent a lava flow from 11,000 feet all the way down to the sea in 8 days. But imagine if a lower elevation radial vent eruption was to happen instead of at 11,000 feet, at 3,000 or 4,000 feet. it can potentially send lava flows into a region where you may have only hours to a few days to respond. And then on the opposite side, the Kilauea side of Mauna Loa, you really have one example of a lava flow from the northeast rift zone trending towards Kilauea summit. That was in 1880 also, and it took over a week for lava flows to get here. So we suspect in this area that you will have days to weeks to respond. And the other reason for this color is that this is an area of low population density. I suggest you look at the video for in-depth discussions on this color-coded maps. The other things that we have created are lava flow inundation maps. These maps exist island-wide for Mauna Loa volcano. This is a map for the Hilo area, from Volcano down to Kea'au, out to Hilo, all the way back up to the saddle. These maps were made for emergency response activities and for planning. How are these maps intended to be used? The Hawaiian Volcano Observatory should alert people island-wide that Mauna Loa volcano is erupting. If the dike moves into the northeast rift zone, the Volcano Observatory will provide the elevation and the general movement of lava flows. So in 1984, the lava flows arrived at an area about here, 9,300 feet or so on Mauna Loa's flank. The flows were trending in a northerly direction, which is represented by this burgundy polygon. Waiakea region of Hilo is represented by blue, and from Volcano to Kea'au is represented by pink. So in 1984, these maps did not exist. And so the next view is the view from Hilo. Here is the view from Hilo, where the flows were trending in a northerly direction, and all the people of Hilo from Waiakea to Kaumana were looking upslope and wondering if their homes were going to be impacted. And at this point, given this view, all of Hilo was terrified, thinking that lava flows were heading in their direction. Now that we have these maps, we can see that the flows broke out and headed into a northerly direction into this burgundy area. The early flows were actually occupying this area towards Waiakea, but they quickly shut off within a day or so time, and this vent took over and sent flows in this northerly direction. So the people of Kaumana, if the flow had sustained enough activity and duration, enough lava from the ground, could be the portion of Hilo that could have been devastated by the flow. The people in Waiakea now didn't have to worry about lava flows, and they, having had these maps, could look up slope and recognize that they would not have to be planning and possibly not worry at all. And then, of course, the volcano area is in one polygon, and to see an explanation of why all of these communities are in the same polygon or lava flow impact zone, please visit this video for an extended discussion. So, developing a plan. The components for developing a plan is to make a plan, to have an emergency kit, to recognize the hazards, and to sign up for emergency notifications. Now, there are many websites that deal with various aspects of this plan, and I will go through briefly some of the things that are a part of each one of these components. Now, the emergency plan is good for all disasters, not only volcanoes. It's important for hurricane, fire, tsunami, floods, and earthquakes. So this plan can be utilized for all natural disasters. In the plan, you should have contact numbers that you'll need. Should include things as the primary phone numbers of you and your ohana, where they might be. You might want to have people that's out of state that you may want to contact in case the local infrastructure that deals with telecoms is down. So you can call the mainland and talk to a relative who may talk to some other relative of yours. And so that will be the central locating point. You also may want to have numbers for your doctor, your vet, your insurance. Recognize where the important locations are. Where are you going to meet up with your ohana if you guys are separated? Where are you going to stay? What emergency shelter is available for you? Is it pet friendly? Where is the hospital? Provide this information for every family member. Visit this website to get further details. You may want to have an emergency kit, like quote unquote go bag. And in this go bag, you may want to have identification cards, driver's license. Where are your bank information, your credit card numbers, your insurance? You know, copies of your deeds and your prescriptions. These are the things that you would pick up in a hurry as you're running out the door as the evacuation is occurring. Now, these are things you want to have pre-positioned before the Hawaiian volcano says that there's an eruption at the summit of Mauna Loa, especially for those of you who live in areas in which the lava flow can rapidly come down the flanks of the volcano. Are you ready? You know, don't wait till it's too late. This simplified map gives you an idea of how much time you may have to respond. Making a plan is not only good for Mauna Loa or lava flow hazards, but it's good for any emergency. Be prepared. Here are resources where you can learn about Mauna Loa and its hazards. You can see what you might put in your go bag, an extensive list. There are lava inundation maps online where you can learn about the potential elevations and segments of the rift zone from Mauna Loa that can send lava flows into your area. Or possibly where lava flow cannot come to your area. There might be an area announced that's issuing lava. You can look at the map and say, yes, that's me, or no, that's some other community. Visit online and look at videos for discussions on the inundation zones and simplified color maps, what we call lava response times. And then, of course, there are resources online at the Hawaii County Civil Defense website specifically devoted to preparedness, not only of lava flows, but all kinds of natural hazards. Thank you.